Hello everybody, it is Caleb here, and today I want to rebuild the GLP JDC1 fixture that I made a while ago. And I'm going to be doing it completely from scratch because it was one of the first fixtures I made. And I made that texture in PowerPoint, along with the Asteratube actually. But I want to remake it using light baking and more traditional methods that I've practiced. And I want to also create it in multi-instance RGB and strobe mode so that you can get full access to the 8 cells in the color plate. I think it's 8, and however many cells are in the strobe feature. So I do want to give my Patreon supporters a thank you for helping me kind of stay in the right direction on the MVR workflow and what fixtures they actually would like to see. And yeah, I'm going to be building this fixture from scratch. I don't do that a whole lot, especially if it's a complex fixture. But this is something I've been wanting to update for some time. And so I figured it would be a good time to just document the entire process. You might see some mess ups, I won't lie. I'm doing this based off of my experience building the ROX S2 strobe. So yeah, let's get started. So the first thing I'm going to do is just go to the internet and pull some of the information for the JDC1. "12 segments of RGB and 12 segments of strobe." The next thing I want to do is get the dimensions. I should be able to just... Alright, this should do. So the next place we're going to go is good old Blender. And let's say hello to our default cube because we're going to keep it this time. I'm going to open this little window right here and then go to my dimensions. And what I might want to do first is go to this cone here, since it looks like everything's in millimeters. And go to units and give it millimeters as the default. And now all these dimensions turn to millimeters. So now I can specify that the head is 178 millimeters tall. ,390 millimeters across. I don't think it says how. Oh, about 154, maybe 100 and... That's probably 145, I can guess, if the base is 154. I'll go 140. Alright. So that is my basic head. And I think I saw some drawings. So yeah, there is a border that goes around it, which I'm going to want to retain. So let's say this is the face. Let's go to 3. I hit number 3 to get this view, and okay, that's my face. So I'm gonna want to, let's try just bringing this face in here. So just with this face selected, I'm gonna hit E and then S to scale it down, and then SZ just to square that up. Now I have something that looks like a face. I can press E to extrude in a little bit. I could give it a little bump in the center. So let's hit Control R, and I'm going to scroll my wheel up once. Double click, and then hit SZ to bring that in. And then I'm going to hit E to extrude. And I normally don't like to leave two faces touching, but I think in this time it's okay. So I'm going to hit GX and bring that in just a little bit more. And then bevel this edge. So select these two edges here. use the bevel tool and just give it one segment. I don't want a complicated mesh. It looks like it does get quite a bit smaller in the back though, so I might want to make an attempt to depict that. So to do that, I think I hit E to extrude at one point. Yeah, that should work. All right, so it seems like I got some overlapping points already. Not exactly sure how, but if you ever are faced with this problem where you have duplicate edges, the easiest fix I found is to enter wireframe mode, select all the affected points, and then hit M for merge, and then do by distance. And then here you can see removed 8 vertices. 1, 2, 3, 4. That should be good. So let's go ahead and just click out to OK and accept those changes. And now we should be able to bring this mesh in. Hit E for extrude. And then we're going to scale this down just a little bit. SZ, and then extrude it back. That looks similar to the fixture. And give these one bevel as well. And by the way, if your bevel is not at a perfect 45-degree angle, it's probably because when you started on this cube, you used the S or scale feature instead of giving it dimensions. And so if you transform it, you'll see that there's a scale here. I don't know why this changing affects your bevel, but if you size it down using dimensions, it's a whole lot better. That's as many vertices as I'm going to want to give this mesh. You don't want to make your mesh too complicated. What we're going to do is rename this as basic mesh. We're going to duplicate it, and we could just hide one of them, but what I'm actually going to do is kind of fly it up and out. So I want to remember how far it is though. So GZ1, which means grab, didn't move it. It means grab and move on the Z axis for 1. But didn't, oh, because I'm using millimeters. So I'm going to go GZ 1000, GX 1000, and GY 1000. That should get it out of every single of these 1, 3, and 7 viewports. Now I'm going to hide it. And this one remaining, I'm going to call it my complex mesh. And this is what's going to be used to bake your lighting in. And so you can see on the JDC, we've got all these little LEDs on the RGB plate, and we're going to make those first. So to do that, we are more than certainly not going to add every pixel individually. What we're going to do is look at these and do our best to make a diode. Let's see if we could find a close picture. Alright, so it looks like a small square with a diode that has the color and then 3 wires going in and out. So what we're going to do is make a little, in object mode, add a little cube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going down. And I think, let's delete this for now. I think Blender will let me measure, actually. So I think what I'm gonna do, so that I can see better and no one has to know, is hold Alt and click this ring here, and then just it's a two-dimensional ring, so I don't have to worry about it moving in and out. I just want to move it to the side a little bit so that when I hit 3, I could see what's going on. I don't even need that much. I just need a little bit to see the edge. And now what we're going to do is I can measure this. So about 66 millimeters. And I got to get 10 of those. So that means each diode is going to be about 6 millimeters across. I'm going to do 5 millimeters because that sounds more like it. So 5 by 5 by 5, and then we'll figure out which one is depth. That looks kind of big. Possibly. We'll find out in a second. So I think the X, yeah, is the depth. So let's just give that a depth of 2 millimeters. And then since these are going to be baked from this angle, we do want to cheat a little bit on this one as well and just scale this front face in so that we can make out a little bit more detail on the square. Okay, from here, we're going to position this in. And then go to modifiers, and we're going to add an array modifier. We want to only have a factor y and then eventually a factor z. And I think I'm going to, let's test the factor z first because we've already counted out 10 pixels going that way. So I'm going to drag this down to the bottom. And then up this by just a little bit and try to give us 10 pixels. Cool. So it looks like perhaps this object here why does it say 59 millimeters? That's probably the bounds of it. All right. So if you disable it from viewport, you can then resize it. Let's give it 6 millimeters by 6 millimeters, like I thought. And then turn it back to viewport. Oh, maybe 5.5. Cool. That works for me. Now what we're going to do is work on this mesh just a little bit. So you can see that we're not affected by these other arrays. As we add detail to this, it'll copy over to all these other instances. So what I like to do is hit / or / to take this into what's called like a solo view, and then we can add more detail there. So I think I'm going to bring this down a little bit, make it not as big. And then it doesn't have to be a perfect mesh. So I'm just going to take a cube make it really small, and that's going to be my wire. So I hit GX there and then scale to bring it down in size. So S for scale. And I think what we're going to do real quick, bring this within the bounds of our current shape. Just try not to oversect any lines, because keep in mind that this is part of the same object. So you're going to have to grab this again later. Let's give this a constant offset. Oh, because I'm doing it to the X. All right, there we go. Cool. And so the difference between a constant offset is that if we now bring this up, it won't push out the other ones. It stays within its bounds, and it'll even overlap other meshes. So let's go in again. And I'm going to hit / to bring it into solo view so I can see better. And then I want the top of this wire to just pop up above the diode. Then I'm going to bring these down a little bit, and those are going to blend into the diode. I'm going to select this top here and then hit SY to scale it in more so that it looks a little bit more like a wire. And actually, since this is a I didn't duplicate. Since this is a high poly mode, we could actually go and bevel these edges and give it like 3 segments, and that should look super realistic. And you can see, since I use scale on this, I now have to hit scale X just to make that more round to compensate for that. Now, to make this a little more realistic, I can take this portion here, hit GX and bring it down just a little bit, and then I could even bevel that part. That did not work. Let's do a little less then. There we go. Okay. Now, if I want to get really tricky, and I don't want to duplicate this, I could separate it and it still carries the array modifier. And so before that array modifier, I'm going to add another array and drag it up here. That gives me my 3 wires. And then I can just duplicate that part. I'm not going to get that detailed. Then this would get rotate on the x-axis, or I could just, since I'm in flat view mode, mode 3, or view mode 3, I could just hit R180 and it'll spin the entire thing. Now, I didn't expect that because it's taking the entire array here. So let's just take this one mesh and hit R180. Now it's upside down, and then hit GZ to bring that down. Now we have some wires going into our diode. Next thing we're going to do is just look at our reference again, and it still looks pretty close. So now we're going to add our diode. So let's go to mesh and let's look at this one more time. It almost looks like they're more oval diodes than circle. Add a cube. Scale it way down. I hit scale 0.001. Bring it forward. Go back to view 3. Hit SX to scale it in even more. Now that we have something flat, we're going to delete all other polygons anyway outside of that square. So what I'm going to do, by the way, is hit Control S and bring cursor to my selected. My cursor wasn't rotating around that, and I didn't like that. So let's select both of these. Why is it selecting? Okay. All right, now I'm only selecting that. So what I'm gonna do, working on little stuff is hard sometimes. Hit tab, and then I'm gonna highlight these 4 corners here. Let's give it a couple more edges, and then round it. And then I can go to 3. Select all these points. Turn proportional editing off. And then fit this to my shape. Okay. Realized I don't have my diodes in here, so let's hold shift and get those, and then go back into our solo view. And then we're going to join these together. Oh, I selected that in the wrong order. I think it's first click, and then your last click is the object and selection. So now we hit join, and it'll join all those up. Now what we want to do is go to our view 3 mode. And luckily this is still out a bit. I would want to delete all of these vertices. I think if I delete all these faces, it'll delete the face in front. There we go. So now we have that face in front still with a rounded corners. And we're going to just bring this into about here so that it covers the wires. And now we can start texturing. The body's going to be silver. So we're going to need 3 materials here. All we're doing, by the way, is getting an RGB texture to apply over the entire front of this. So what I've done in the past, and this is always a little bit trial and error-y. At the least we can hit, let's wait on that. Go to 3 and go into solo view with, looks like I need to apply. Let's first apply this. Let's get rid of this one. Get rid of the other 10 modifier. And apply these 2. join these two meshes with this one that does contain our array. Now all of these are about the same. Well, they're exactly the same. So I think what would be easiest is just to select all faces by hitting A. And we're going to go new and then make some names here. Okay, so our body is, we could raise the metallic. I don't think it's going to do too much though. And we can go hold Z and go into material preview mode. And it is sticking a bit above it. I don't know why I could see it there as opposed to the other views. But if that's the case, let's raise it up a little bit. I guess it is really close. Oh, I need to turn on wireframe mode by hitting Alt-Z. Now I can see through and select through faces. It's still doing it. Can't figure out why. Anyway, that's as long as it doesn't make it over to the bake, it's fine. Okay, our body should be about good. Let's change this name to diode body. And then on our complex mesh, we need to give this another material named body. And then make that black. And then for our wires, we can just, with X-ray mode enabled, that should help, select all these faces. And if you hold shift and then click that single point there, you can deselect that face. Then these I'm going to assign to wire, which is going to get a more, I don't know how to make a copper look. Are they copper though? No, they're kind of just a different silver. So I think just the 3D aspect will be what has to take these. I will make it a brighter white though. Okay. And then for our emissive diode, we're actually going to give it the unlit version here, which is still white. So then its base color, whoops, emissive diode. Just take this one, assign it, and it is as white as it can get. In fact, I am going to gray it down just a little bit so that once it lights up, it pops a little bit more. And so that's sort of the diode that we're looking at. I do really want to get rid of these things here. There we go. So what's going to happen is all of these diodes have to be, we're going to bake a texture. And so all these diodes have to land somewhere on a UV map. And then whatever texture or emissive qualities they have, I don't know what tab I was in, but whatever emissive or base color material qualities they have are going to be painted onto the UV map. So let's position our diode cells. I mean, we're going to add another array. And that is going to be on the factor, well, it's going to be a constant offset. On Y, of the same, 2,380 millimeters. Maybe we can space it out just a little bit more. There. And then just keep adding. And the only thing you want to make sure of is that this can be divided by 6, this number. So 55, I don't think. 56 probably can. No. 48, 54. Okay. So then that's going to be every 9 pixels across. So let's go to 54 and just try to make this fit. All right. Now what we're going to do, let's do an incremental save in case we have to go back to where we are. So I'm going to hit Control S, call it JDC1. So what we're going to do is apply, well, let's duplicate this first. Down. So I hit Control D there. Was it Control D? No, Shift D. And then apply all of these modifiers. And now we've got a whole bunch of pixels. So what we got to do is get these onto the UV space where we're going to be painting our texture eventually. So we can select both of these. Tab. Just hit A for all. Go to UV editing. Hit 3 and zoom in as far as you can because your view is going to determine how these map. And then we're going to hit UV project from view. Now we have all our little diodes on our map. Let's hit A and S. And our computer might bog down a little bit here, but that's okay. Try to get this centered. It doesn't have to be super critical. And then scale it up to get as much detail as you can out of these pixels. From here, now we can kind of test what happens if we go to bake this. So we're going to go to shading. And this part is where I get a little weary. But we're going to create a new image in the shading tab here by clicking on this new button. It's not going to have an alpha layer. 1024 pixels is enough unless we feel the need to up it from there. And let's call this RGB base color or something. Hit OK. And now we're going to add a reference to this image in all of these materials so that when we hit bake, it's going to follow that image reference. So we do that by hitting Shift A, image texture, and then just select RGB base color. And then we can take this texture or this image node and hit Control C. And in this slot drop down, not on here, because then we'll be changing textures. We're going to drop this in all of our things. And then we can click on our object here. And that even includes this body. We're going to drop that in here too. Even though they're two separate objects for now, we do want to join these so that it's one big object. And then let's build our center strobe cells first. And actually, to do that, we're going to want to flatten this a little bit. We can bring it out. Well, it's going to be out on our default texture. Now what we didn't do is UV map our basic mesh before we did this. That's going to come around to bite us a little bit, but it's nothing we can't overcome. All we have to do is fit the texture that we create to the basic mesh. I'll show you how to do that. So with this flatten, we're going to make some diodes. So let's look in here and count the diodes. 216 LEDs going across there. That seems like a lot. Oh, because it's 3. I'm just going to do one big tube. Copy our existing LED. I'm going to Control Z that. And then have wireframe mode on so I can copy the entire diode. Okay. And then this front little square right here, I'm going to select that and then just scale that up a little bit. Let's do this. P to separate this, and then with just that selected, let's just shape this up a little bit. So I'm going to select everything on one side, hit scale Y, and make it 0.3. Do the same to this side, SY 0.3. And then on both of these, now I can go out of this and kind of return this shape to the main body by hitting click first on this, and then join after hitting right click. And then just bring these out a little bit. And just a quick note from me editing it, now would be a good time before we apply the array to take this single face of diode and assign it to a new material named diode yellow. That should be good. If anything, it'll save me from the IP rights. So now we're going to try to grab all of this mesh here. And if you got yourself into a predicament where this is now overlapping other meshes, good luck. You could always just hold shift and select points as you go. So I'm going to hit P, separate selection, so this is one object now, and then apply a modifier to it. And that is going to be an array with a Y offset. We can do relative offset here. And let's just not really care about pixel count, except that it has to be divisible by 12. No, I didn't think so. What is divisible by 12 then? We're like right in the middle. I know 60 is. That's close enough. We could also, once we have all this, we could just hit S for scale and then Y. And just scale it down a little bit so that it fits. Okay. For the complex mesh, then we could probably get away with just deleting these faces here. And that just exposes all of this. Assuming that we join these two faces back up. So let's shift select both of these and hit F for fill. And now That hurts. Let's see if we can bake it anyway. Basically, there's a hole right here between these faces. But we can't easily fill it because this, you know what we can do though, is just click here and hit F, maybe. Oh. Let's try to live with that hole. It should be, it's definitely nothing that we can't touch up in Photoshop. It'll be a couple pixels that gets messed up. So let's go to Material Preview, and there's one thing I want to do that I probably should have done when it was in array mode. That is to make all of these yellow. Okay, we're going to go to Materials, make another material, so plus a new. And we're going to call this emissive diode yellow, because these are more than definitely yellow. And then assign those all to it, because I know it colors shapes that are selected. That should be good. I think I want to make it a little more yellow. So you can click, once you have them all separated or on one material, you can hit emissive diode yellow and just select, and it'll select all those faces for you. So let's make this a little more saturated. And I'm happy with that. What we're going to do now is, this is all one object, a very complex mesh. So we can select all of this and say UV unwrap project from view. And it's going to give us one big pretty face. And what we're going to do actually, because the diode area needs the most detail, we're going to stretch the diodes S to cover most of the available texture space. And then everything here, we're just going to cram it into the sides. And so the sides of the fixture might stretch their texture a little bit, but it's just going to be a solid color, so it doesn't really matter. Now, because we UV unwrapped this from view, there's a few shapes out here that don't quite get the attention they deserve, or they overlap other UVs. So what we're going to want to do is just take all of those segment by segment and UV unwrap them differently. So let's go UV unwrap. Now we get this portion, and we can just scale this down to a pretty small size and fit it however we can in the mesh. I know that up here is free real estate and down here is free real estate. So I can do the same with these, and actually all of these polygons too. I already got the top and bottom. So yeah, let's do these, unwrap. And then these can live down here. And now if we hit A, we can see that we have a bit of a cleaner plate here. And then these textures have all this area down here. That should be good. If we want to get more detail on this, we can. but it's not really important. The sides of the fixtures might be important. Now what we're going to do is our good old texture bake. So let's play some trial and error on this. I'm going to go to shading. We have to drop this node, this texture node, into one more slot, and that is the emissive diode yellow. And then I'm just going to check over all of these to ensure that it has it, which it does. So all 5 of these textures have this base color image in here. That means that when I bake this object, all of these materials are going to look for an image texture to bake to. So let's save first, Control S, and then go up to this little camera here and hit render. And we need to change our render engine to cycles. You want to trial this error out with less samples. So just do like 64 samples per, and it'll go much faster. And then if you want to upscale it from there, you can. So with your textures, with your object selected, hit bake. And it looks like it got nothing. So I did get pretty decent results just now with using direct lighting on here. So I think what I'm going to do is go ahead and continue to use this directional light here. And then I'm going to duplicate that. And now this back has some light. All right. So that got the image texture that I need. It looks like the solution is to leave your lighting on both direct and indirect and just add really dim point lights here. So I changed my power to 50 and just use those to light up your scene. Once you're done, you can, if you want to, you could delete them or you could just turn them invisible. Now what we're going to do is save this texture so we don't lose it. But it's going to remain in use inside our program. So we can hide our complex mesh now and go back to our basic mesh. And then hold Z and switch our rendering back to solid. Now what we're going to do is apply this texture here to our fixture. And we're going to do that just by kind of doing the same thing we did to our other fixture. And like I said, I probably should have UV mapped both of these objects together so they are exactly the same. But it's not that hard to get them to match up. And so what we're going to do is hit 3. And then select all of these faces here without selecting the ones behind it. UV and project from view. And then go to our UV editing here. We can see that we're kind of given the same shape. We're going to want to use that. So let's do the same thing again. And kind of compress these in. And you could select both of them and just hit SX for scale X. And then what we're going to do in this image here, I think there's a different, yeah. Click here, down here, and then you can bring up your RGB render. And now you can form this exactly to your render. Make sure everything aligns. Honestly, I got pretty close the first time, surprisingly close. So like I said, it's not the end of the world if you didn't unwrap these together. And now what you can do is on this material, which you might want to give it a new material and remove this one. This is going to be called low poly. And under base color here, you can give it an image texture of the RGB base color and then switch to material preview mode. And I should be seeing it. Oh, because we have to select all faces and hit assign. So now you can see the point of this. We've created a high poly mesh, created a texture out of this, and then applied it to a low poly mesh. And so now we've got some faces on the outside of this that we need to take care of. So let's select all of these. Hit UV unwrap. A for all, R for rotate, 90 for 90. And try to loosely scale this to match what we did on our high poly model. Again, no one's really going to look at the side of your fixture, so you don't have that to worry about. UV unwrap, it did it the same, cool. Nope. I was looking at how these pixels kind of bled into this texture, but it seems okay. So there we go. Our fixture is textured. And then we can probably do some Photoshop and just kind of black that out. I don't think we needed to bake that end. Now what we're going to do, let's save our progress so far and switch back to our high poly mesh. Now we're going to create various, well, only 2 textures, but we're going to create the cells as if they were lit up. So we know here that we gave this, I forgot how many instances we gave it. I think it was supposed to be 9 across. Yeah, because we gave it... What's 9 times 6? 54. Yeah, we gave it 54 pixels across. So we can select everything here and then factor out what we don't need, because all we need are these emissive things here. So let's highlight these, go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then go all the way down. Okay, we're gonna hold shift and take out that. That's fine. I didn't turn on X-ray mode, but we're only selecting these flat things, and we actually want to deselect things. So all we're after is emissive diode. And so we're going to go to diode body, deselect, wire, deselect, and any emissive diode yellow, deselect. Now we're going to make a new material called light. And here we're going to go to emission and turn its strength all the way up. Or we could probably just turn it to 1. From here, we can assign all of these to it, and you saw it light up a bit there. And now what we can do is go to shading and copy, well, we have to make a new image anyway. So we've saved this image already. Let's go to image, new. This is also a 1024 texture. Let's call this RGB lit. And then just in here, hit Shift A, image texture, RGB lit. And then to not let this bake again and either override our work or because we deleted our point lights and we don't want to reactivate them. We don't want to delete our old work, and we don't want to cost more computing power than is needed. Okay, so this is the only texture right now that contains an image texture. So what's going to happen is these lit cells, I'm going to hit bake, and these lit cells are going to bake to this texture in only that area. We could actually leave lighting on if we wanted to, but it is going to capture the emission, and there we go. Now, one thing we want to do, because it thinks that this area is empty right here, we want to turn our margin to either 1 or 0. I sometimes like 1 because it gives it a little bloom effect, but this is what it would look like with 0. I'm going to do it with 1 pixel growth so that there's a little bit of a bloom effect on it. And then I'm going to save this texture. And then we can create a new image. So hamburger icon, image, new. We'll call this one strobe lit. And then we could delete this. We're not going to use it again. Everything that is currently the light texture, we have to be in tab edit mode. Everything that is the current light texture we select, and I want to restore that to emissive diode. And then here we got to count up. I'm really not good at remembering numbers today. All right, 60. That was kind of the number I thought. So 60 divided by 12 is 5. So we're going to select 5 of these at a time and assign them to the light texture. And then run our texture bake again. But this time we're going to add a image texture and give it the strobe lit image, which is this. Now when we hit bake, these 5 cells will bake their position and their lightness to this strobe lit image. So let's go to bake. There we go. Let's save this, and our work in Blender is almost done. Let's save as. Okay. And then what I want to do is just test these textures with our basic mesh. So we know that everything lines up, but we on the base color, but we could also give this a different emission. So under color, let's do image texture, and then drop in our RGB lit and turn our strength to 1. We can see that it lines up perfectly on these cells. And then if we do our strobe lit, it lines perfectly there. So that's what we wanted. We can get rid of this now. And now all we have to do, well, we could get to Unreal Engine now and apply some of these concepts. And then when we come back, we will add the base and the, well, it's just the base. The yoke's built into the base. Control S, save your Blender file. And you can minimize it, but if you're in rendered mode, I would switch out to like solid mode before you go over to Unreal Engine. So I'm going to go to my light fixtures folder. Sorry, this is in fixture content. What am I doing? I learned, by the way, that if you store your fixture content in your fixture content folder, like your actual fixtures, you're eventually going to crash it. And I don't know why. So GLP, JDC1. This was the first texture I made. Totally made in PowerPoint. I don't even think it has a square size. Yeah, it's 815 by 814 pixels. So let's do this a little differently this time. Everything here is going to go into JDC1 compressed, and we're going to have totally new stuff for our there might be some shared assets. So now we're going to have a new folder called JDC1 extended. And let's get all these contents in. So Blender bakes. Someday I'll do the jolt bar. It's on my to-do list. So like another fixture, by the way, if you're concerned about baking, this was my bake for the Q-Pix. And you can see there's a lot of stuff I did not want there, and I couldn't isolate that light away. And I finally realized that 30 seconds in GIMP or Photoshop, and I can just erase all of this as needed. So what you want to bake for is for quality and accuracy. But what's outside of that area of the first cell, you don't really need to do much with. So let's drag all three of these files in here. And then we forgot to export this. So let's go back to our basic mesh. Export, FBX. I'm going to take this to Blender Exports. JDC1, and then you want to limit to selected objects, otherwise it's going to export your high poly. Now we can go to Blender Exports. Find wherever the heck we just put it, JDC1, and drag it in. And don't worry if there's no smoothing group. That's okay. So we can drag our JDC1 in, and it appears what happened is we didn't move it back. So let's take this, go GY negative 1000, GZ negative 1000, and GX negative 1000. The reason you want to do that is because Unreal is going to rotate it around this point here. And if this point is way off, it's going to send your fixture flying. So re-export. And then you can just bring back in the same file and it'll re-import it. So here we go. I'm going to scale this up so you can see what we're doing a little better. And if any light was that big, I would run for my life. And cool, we have a fixture. And because this texture was on there when we exported it, our, I'm going to call this, our base color is already on there. So that's cool. All we need to do now is apply our lit textures and then link them to our blueprint. which we're going to make in a second. But for now, we can have just a static mesh floating out there. And so for some of this, if you do want to work in full screen, hit this flat button here, or you could even select this static mesh and then hit this little brick icon here, and it will apply your material to the static mesh, which I think is kind of cool. So let's go with that option. What we're going to do is drag in our textures. So let's do the RGB plate first. And we are going to make a material function here. But first we're going to draft out what we need in that material function and then cut and paste it over. Alright, so if we run this into our emissive color, we light up our first cells. If we offset our UV texture by a little bit, we're going to move over to our second cell. Alright, so what we need to do is figure out how much we need to offset this texture by to get it to light up the second cell. So to do that, what I would do is multiply this and hold down 3. And then make this a different color, let's say blue. And then we're going to put that in our emissive texture so we know exactly where it is and where it stops. Now we're going to offset this texture. So let's right click, do texture coordinate, and then break out float 2 components, because we are going to have to drop these along the x-axis and the y-axis. So let's go out from here and say add. And then this is going to become a parameter. And then we're going to make float 2 and then do the exact same thing with this one. We don't have to name this parameter because we're going to drop these to constant values anyway. So let's apply that. And what I like to do is use the actual mesh for this because it updates in real time. Oh, and then we need to drag this out and then add it to this. Now we have both of these overlapping the same. But if we slide this over, we can access our second cell. And you want to take some time to dial this in as close as you can. So I might even think this is right about there. So 0.161 is our number. Do you guys see what I see? Where's the top of that? And why is it so dark? I think it's just the shadow. Yeah, it's just the shadow because we have a directional light. That tripped me out for a second. Okay, so 0.161. So what we're going to do now is actually just say this number, we can drop this to a constant value now by right-clicking in and saying convert to constant. And now this is just going to be our instance. So this is going to run to here. And then this we can promote to a parameter. Have it out here because this is going to be kind of an input to our material function. And I'm a little conflicted on this sometimes because it takes more math to do it this way. So I think I actually am going to do it the more basic way this time to keep the blueprint as simple as possible. So that means this is going to live outside the material function, and all of this is going to live inside. We could work on our y now and find that number. Looks like our directional light's harassing us again. Okay, that looks accurate. Convert this to a constant. Now let's make our material instance. Or our, not our material instance, but our material function. So we can promote this to a parameter as well. And this is going to be our texture object because we're going to have two different texture objects here. Our strobe cell and our RGB plate. And then the other function we need is to add in our previous color. Well, we need our pixel color too. That's right. So hold 3 and we get an RGB vector, and then we can convert that to a parameter. And this is going to be in our final material graph. So let's call it just RGB_0. We need some way to differentiate the RGB pixels from the strobe pixels here. So this is just going to be a solid color. Let's give this texture our, give it this texture object. So that's going to be RGB lit. And then this is going to come out white from here. So we multiply in our color, which for this case we'll give it green. And then we need to add in the previous cell to that. So let's go plus. And then we can do this in the material function. So let's copy all of this. Or yeah, let's copy it for now. Right click down here in our content browser and let's make a material function. And honestly, I feel like this material function can be consistent across many different types of fixtures. But I haven't tested that one yet. So as soon as I do, I'll let you know. Let's open it. And then we're going to Control V, paste in all of our stuff. And this is going to be what runs to our output nodes. So now we just need to make a bunch of input nodes. So one function input is going to be a scalar. And that's going to be our X offset. We're going to have another scalar that's going to be our Y offset. We're going to have a vector 3 that is our pixel color. And then we're going to have a vector 3 that is our previous texture. Our X offset is going to be linked to this R to X. Our Y offset is going to be linked to here. Our pixel color is going to get multiplied by our output here. And then our previous texture is going to be added to that. Once we do all that, we can save this and then drag in our material function and delete all this. And even this and this and this. Now, is this a texture object? Because it looks a little different. Yeah. I want just the regular texture object. And so this is going to be, we can just search here. JDC1 RGB lit. It looks like that needs to be an input as well. So let's right click, texture object. This is in our JDC1 pixel placer material function. And now we can take a texture object into our actual texture that we're offsetting here. Apply that, and our pin should have showed up there. So we might just need to bring it back in. Where is it? Oh, you know what? I didn't do a input. So we do another function input. And this is function input texture 2D. And that links to here. Then the other thing you need to do, now that I think about it, is this X and Y offset won't always be used. So we want to check use preview as default so we don't have to add in and previous texture won't always be used, so we can use preview as default here too. So these three get turned to use preview as default. Let's save that. And then in our actual node graph, now we see these textures show up. So our texture object goes to here. The other thing we can do in here is organize these. So sort priority here dictates where they fall on the material function. And so I like to raise, it doesn't have to be perfect. Like you can have one of these at 10. But let's just order these. So 0, 1, 2, 3, and maybe I can make a -1. Yeah, just to put it before all of the other ones. And there we go, it organized them all. So for our first pixel, we don't have to use X or Y offset because according to the JDC1 documentation, which I had to restart, so according to this, number 1 is in the upper left. So we don't have to do anything here because if we link this to our emissive color, what's the error? Oh, we need a pixel color in here. Then it shows up on our cell 1 position anyway. What we do need is these going forward. So I like to arrange the material functions kind of how the cells would line up. So 1, 2, 3, 4, 5, 6. Our base color can just live anywhere. And then we just run these results into each other. And then without multiplying anything yet, drop one of your constant value above each of these. And then we can actually take this whole thing, Control C and Control V, and copy it down here. Now what we're going to do is this is offset to cell position 2. If we multiply this by 2, it'll offset it to position 3. Multiply by 4. Multiply by 5. And multiply by 6. And you just type star and then 6 there, or a number, and it'll do the math for you. This should never go above 1. We could actually delete these and copy these down here. So now if we wire these into our X offsets, and then give all of them a pixel color, and all these pixel colors will have to have a unique name anyway, so let's do that now. Okay, that makes more sense. Now if we wire these in, and then share the same texture coordinate for all, and I should really rename that to be like texture in. It might not update it in here. No, it didn't. Now when I run this to emissive color, all 6 of these should light up. Something went awry. And I don't know what. Which cell is it? So let's take it one by one then. 1, 2, that one's good. 3 is good. 4 skips to 5. So negative 0.161 times 3. I think I see what's happening here. Why is that down there? Negative 0.161 times 4. But that's not taking effect yet. I don't see any reason why I would have that down there. Unless that's just how it was UV mapped. So let's try looking at this. And yeah, that's it. So it's just an error on my UV mapping. It was doing the right thing. I don't know that these two need any real space on the UV map. So let's just UV unwrap these. They're going to end up somewhere. Let's just tuck those aside and pretend they don't really exist. They'll be the color black. Export as an FBX again. And then when we re-import it, it should just get rid of it. Because I reset my computer, link to selected objects was turned off. So exporting just my basic mesh. I was wondering why it took so long. Now I can re-import this. And now things should be solved. There we go. So now let's keep linking these in. See if we can make it all the way across, which we did. Except on the last one. So I think it's just because I got incremented one higher than I should. So negative 0.161 times 5. There we go. Now what we're going to do is the same thing to the bottom row. And then rename these accordingly. So the last one was 5, this is 6. Let's use the correct values though. And then our Y value is going to be the same for all of these. And then our result from our index number 5 goes over here to our previous color. And if we want, we can bring this all the way up and around to kind of keep things clean-ish. And then texture object, that remains the same for all of them too. And then when we wire this one in, we should get all 6. Looks like we missed one Y offset. There we go. That is all of our RGB colors. Now we have to do our strobe colors, which gets added to this as well. So let's do that now. We're going to use the same material function. It's just our texture object is going to be different. So we can copy this down and then just change this to JDC1 strobe lit as our texture in. And then we would have to discover what our offset value is. So let's take this over here. Give it a pixel color. There we go. Then let's find out what our offset value is. Okay, so let's increase this. I'm going to go to a flat view here so I can get a little closer. Let's try negative 1.61 divided by 2. Hey, that's pretty close. I think I'm gonna go with 7.9. So convert that to a constant. Now we can kind of bring this assembly down here. So this is going to be 12 going across those. So we got to get them in a little tighter than we did up there. 1, 2, 3, 4, 5, 6. That is 1 short 12. That should be 12. So this is our strobe row. The toss-up is it more efficient to use 2 different material functions or to always add them together? I think it's going to be more efficient to use 2 different material functions. So I'm going to find my pixel placer, and rename this color. Then this one is going to be scalar. So let's do a little bit of changing around up here. Our color is not going to have this. It's not going to have the add. It's just going to get multiplied straight in. That said, it doesn't need this texture input node if it's always using the RGB lit. And then in our scalar, we can get rid of this as well. Change this to the strobe texture, delete our pixel color, and then run this straight in as well. And now we're going to have a bit of work to do over here, but not so much because it just disconnected stuff, so that's cool. So now with all of these linked together, if I run this into, oh, these need to be a different material function. And then if I run number 1 into here, cool. So now I just need to copy and paste these. And then rename them all. And yeah, I think I have too many here. Okay, so we can delete these. Now we just need to do our math here. All right, that makes our strobe all the way across. So now we can run this result into our previous texture and try to make our wires neat. And there we go. We now have the basic mesh for our JDC1 made. Now we just need to work out the blueprint logic. So we can delete that static mesh from our world. Don't delete it from here though. We still need it from your content browser. And then we're going to add in not a blueprint class. I used to do that. Now what we do is go to our copied engine content, which is derived from our plugin content under DMX fixtures content, light fixtures. So we go to that and we will bring in a moving head because that's the closest to what we're using. So drag, drop, copy here. This way, its parent class is DMX fixture actor. It will fit into the MVR workflow. And we can add components or have it receive DMX while it's in the editor. So a couple things we need to do to this before we make it JDC1 ready. And the first is find it. And this is always weird. I'm holding right click and then I'm going to scroll my mouse wheel up to change my zoom speed and just try to navigate in here to get close to it. We could probably keep our tilt component. Our pan component's going to be deleted. And I like to compile it every time after I do this so that I can make sure that nothing's getting messed up. But our tilt component is going to make our head rotate on the yoke. Basically, the base is just going to be one giant yoke. We can delete our color wheel component, our gobo wheel component. Dimmer could stay, strobe could stay, zoom can go, frost can go. And now we have a problem. So undo some of that. So maybe these will stay. We're just not really going to use them. All right. Our head, our static mesh head, is going to be our JDC1 static mesh. Rotated 90. Oh, that's location. And then our yoke, let's just get rid of this mesh for now, and we'll add in our base once we build it. So we can just hit this reset button and it'll get rid of it. And then base, let's just get rid of that too. And now all we have is our static fixture. So what we're going to do is work off this on data received pin here. Now the tricky part when we go to build our DMX profile, I'll show you. In our JDC1, we can add red, green, blue because it's the entire plate, and two different dimmers for the I think white is for the strobe cell and dimmer is for the RGB plate, and those correspond to different dimmer channels in the console. You know what? I bet you we can just add this to this mode here. Yeah. All right, so we added this mode to our JDC1. Now the trick here is we have to have two different types of fixture matrices, which we can't do. So we go to fixture matrix enabled, and our X cells is going to be 12. And you can see the problem here. We make our RGB plate, and now what? We can't add a second fixture matrix for dimmer only. I've tried. You can't add dimmer to this because then your instances are going to be all off. These go in, the channel layout goes in red, green, blue, and then the dimmer for the strobe cells comes later. So what we're going to do is actually just add a whole bunch of dimmer channels. So we only have one cell attribute for this. And this is going to be 12 RGB cells times 3, which gives us 36, plus another 12 for the strobe. So 48 channels. And we're going to have tilt and stuff in there too. So let's actually find out where that lies. Okay, so here's what we need. Individual pixel RGB and beam individual pixel intensity. So this looks like the, let's look at some of the other modes real quick. This looks more like it. It doesn't have the effects. What was the layout of the other one? 62, yeah, 68. So let's do, I don't know a lot of people that use those effects, and I'm probably not going to program them in. So let's do SPix Pro. Yeah, that looks correct. So let's go with SPix Pro. And we do need to build this. I would normally import a GDTF. These ones are a little different. So coarse tilt. That goes to tilt. Oh, okay, fine tilt. So this is a 16-bit. Let's get this in a second. Beam intensity. That would be a master channel. So let's do, I'll do white for that one. Okay, what's next? Beam duration, I'm going to skip. Beam rate, I'm going to skip. Beam shutter, I'm going to skip. So let's go down to 6. Obviously, there's no control channel. Okay, 8 is our plate intensity or our RGB intensity. So for that, I'm going to use a dimmer channel. And again, these are just so that I know what to find on the other side in my blueprint. They don't actually do a whole lot. Okay. Plates red, green, and blue. I'm going to want those. And I can only hope that these instances fall next to each other based on how I'm doing this. So pixel 1 through 12, and then beam pixels. Cool. So then at the end here, 12 to 62. Wait, 15 to 62. 62 minus 15 is 47. Yeah, that should come out to 48. So now we add in our fixture matrix. That goes all the way down to the bottom. And we're just going to add in our cell attribute of dimmer, and that's all. We're going to convert these dimmers to RGB sections. So let's save this. And then here's how we're going to handle this. Disconnect these, because we're not going to use them, but I want to keep them just in case. So look at my ROX S2. Pure 1. So it looks like I did some resetting of parameters, get all matrix cells, and then I iterate through all of those. The array index is what drives whether it's a RGB value or whether it's a strobe value. So what I did is I made a offset slash RGB map. So the offset pertains to the index of this array index. And I did that because there was this gap when these are all the RGB channels. So it went 80, 89, 90, 91, and then it skipped 2 and went to 94, and I was having trouble handling that. So all of these RGB channels are then mapped to a 0, a 1, or a 2. The 0 means it's a red channel, the 1 means it's a green channel, the 2 means it's a blue channel. That was the best way I can do it. And so then I have my event pin that comes up here after my color has been factored in. And I get my normalized matrix cell values. I don't know why I had to -1 there. My index, which ranged in this case from 0 to 112, my event pin went up to a if branch. And from there I asked the script, or I asked myself, is this item even on the offset or RGB map? That way there's no way I could factor in indexes that aren't RGB values. And so if I use find, if I can find this on here, then it's true. And then I can proceed with my execution. The value that I find, whether it's a 0, 1, or 2, then goes to a switch on integer. So every time this fires, this is going to be coming in, let's say it's 70, starts at 74. This is going to be channel 74, it's a 0. Channel 75, it's a 1, it's a green value. Channel 76, it's a 2, it's a blue value. Restart. Channel 77, find it on here, it's a 0, so that's a red value. Goes to red. Then green, then blue, then red, then green, then blue. And then it does that, I think, 6 times, and then it skips 2 numbers, and then it goes red, green, blue again, red, green, blue. So I'm going to do that same thing here, and I'm always just finding the attribute dimmer. Once I have these 3 values, then I can make a vector out of these 3. So how this is going to translate to from the ROX S2 blueprint to the JDC1 is pretty similar. We're going to start by getting all matrix cells. Which in this case was every instance of the fixture, or was basically the entire footprint. Here it's going to be just the matrix channels, so those above. It's only going to be the cells above channel 12, so 13 and beyond. So we're going to get all of our matrix cells, and now we need to make a variable, which is a map, that is just an index to index map. Or sorry, integer to integer map. So integer type is going to be a map. Second type is going to be integer as well. We can compile it. And this is complaining because it doesn't have DMX, but we just need to give it the fixture patch. And we're good from there. So this is going to be our offset RGB map. So let's start filling in this offset RGB map. There's going to be 12 elements of RGB, and unfortunately you can't just add these in bulk. So index 0 is going to be a 0 or an R. So let's look on our index chart for wherever Pro was. So the plate pixels came before the beam pixels. So that means that index 1 of my matrix cells is going to be red. Oh, I need to change this to something else. What are you talking about? Okay, then I need to change this to something else. Okay, cool. Index 1 is going to be a 1. 2 is a 2. 3 is a red. 0 equals red. 1 equals green. 2 equals blue. 0, 1, 2. 0, 1, 2. 0, 1, 2. This doesn't seem like enough channels. Oh, because I only have 1, 2, 3, 4 instances. So I need 36 of these. 12 times 3. Okay, that should give me 12 combinations of 0, 1, and 2. So then all I need to do this will get all of my matrix cells, and this will iterate 48 times. This one will iterate 48 times. Well, sorry. It won't iterate 48 times. There's going to be 48 items in this array. So if I go for each loop, this is going to iterate 48 times. And this number is going to go up to 48. So then we can go loop branch if, and we go, sorry, not that. We ask, is this item in the script? Or is this item in the map? Is it one of these keys? Because of that, we don't have to automatically stop the script or do any greater than like 30. We don't have to say if it's greater than channel or index 36, don't use it. Because it's not going to find those items on here. Better yet, we don't have to do any math with our array indexes because we've already done the math in our head. Now it's just finding items on a map. I'm not sure which is more performant. I would think this would take up a bit of memory but require less processing time. So we're going to iterate through all of our elements. If the array index or if the element is on the map, we are going to get the mapped number, the 0, 1, or 2, and we're going to do a switch on integer. And then if that item is in the map, we're going to process it. If not, we could probably drop this pin down to process the strobe colors, but let's do the color or to do the strobe values, but let's do the color values first. Our three options are 0, 1, or 2. Let's go back to our reference. I'm just going to dock this tab in here. So in our rocks, after we determined that it is on the map, and apparently we have to subtract 1 from the integer. I'm not exactly sure why. But we then use the array element coordinate, which is a split structure pin of the element. And then we use that to get our normalized matrix cell values. So let's stretch this over. Well, actually, split this pin. And then we can use... And actually, the cell ID should match the array index, but I'm going off of array index. Use the coordinate, break it, and then apparently subtract 1 from our x. So this would actually... Yeah, that's right. That way I don't need 3 get normalized matrix cell values. I just need the 1, and then it decides where that value is going to, because all of these values are dimmer values. So let's connect that to there. And then from here, it's going to go 12 instances, 36 channels, 0, 1, 2, 0, 1, 2, 0, 1, 2, until it hits one of these pins 12 times. And then it'll finish the other 2. So let's take this and create 3 new variables. Maybe. Yeah, and then these variables would be changing pretty rapidly. So this is going to be a float, normal, single. We'll call it red. And then we'll have 2 more of these, green and blue. Whoops. Okay, set. Now we're setting all 3 of these. And the value we are setting it to is the dimmer value that's there, because that's the only value we have. And that goes for all 3 of them. They just receive these at different times. Now the second thing I built, this would need an array element coordinate. Oh, it needs a DMX target. Or else it needs the fixture patch. Okay, the next thing is, I think, to make a vector out of these, but let's look. Yeah. I'm wondering what this blue channel map was for. I don't think we're going to need some of this. for the JDC1 because it's a little simpler than the S2 strobe. But let's figure out why we needed them. If I can't explain it, we're going to figure it out together. So every time it goes through here, by the time we reach the red, green, and blue, like it's going to hit in this order. By the time we get to blue, all of these are correct for one cell. So then we can say set, if I could type, vector parameter value on materials. And that vector is red, green, blue. And the parameter name, maybe that's why we needed that. Well, let me think about this. Yeah, the parameter name, the blue map here was just to give the parameter name. 0, 1, all the way up to 11. I did that again so that I can do the math in my head ahead of time, and I don't need to compute or divide anything to determine if my array index offset is a blue value or not, and if it is, to find the instance number. I just have a map of the instance numbers. So I guess the more accurate name to this is blue channel to instance number map, which is kind of a long variable name, but I want to remember it. So I'm mapping out, by the time I get to the blue channel of each thing, I want to know what instance I'm on, because that information is not given here. It's just 0, 1, 2, 0, 1, 2, 0, 1, 2. So let's do another one of these, and this is only 12 items long. All right, so 0, 1, 0 would be red, index 0 would be red, index 1 would be green, so index 2 would be blue. Oh, I got... So, index number 2 is a blue. So right now I just need to figure out what all of my blue values are. Index 2, 3, 4, 5. Let's see. 1, 2, 3. Wait, 0, 1, 2. 2 is blue. 3, 4, 5. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Real quick, let me get my DMX up, and it'll kind of explain what's going on a little bit more. If I go into my DMX activity monitor here, keep in mind that my JDC1 is coming on Fixture or Universe 2. We're going to see it come up right now. So select my first 12 instances, and those are the ones that have color. So now if I bring these values down, address 21, I thought it was a different number. Starts on 15 for me. Looks like I don't have this profile available. So that said, I'm going to want to adapt to what MA has. So I'm going to want to change this. And I'm just not going to use the patterns then. So this is the mode that's in the MA. So I'm gonna adapt to this channel instead of expecting anybody to use this to download a different profile. So that said, let's go through this again. 1 is tilt, 2 is also tilt, 3 is intensity or white of the beam, 4 is dead, 5 is dead, 6 is dead, 7 is dead, 8 is the same, dimmer, 9 is dead, 10 is dead, 11 is dead. Okay, that all seems the same so far. I gotta stop clicking on that. 12, 13, 14 is plate red, green, and blue. Ah, here we go. And then I just need to add in 2. Well, probably more than that. Okay, 15 and 16 are dead. 17 and 18 and 19 and 20. Plate master. What's the difference between plate master and plate intensity? Oh, just for the bat FX. That one's gonna be dead too. And then our fixture matrix starts at 19. Almost. Yeah, 12, 13, 14, red, green, blue, that's correct. 16, 17, 18. $19 and $20, those are all dead. And then 21 starts us off with our matrix, our plate background pixel 1 through 12. Let's just see if that takes us to the end. Yeah, it does. So those are all pixels. So let's get back to it, and I'm going to call this SPix68 channel. And while I'm at it, add some description to this one. Okay. So now in our blueprint, we've gotten our RGB values. Right, I was explaining this. So all we've done with our offset to blue channel map is, if this is 0, meaning this is where our matrix values start, we just did 0, 1, 2, and that's a blue value. 3, 4, 5, and that's a blue value. 6, 4, 7, that's a blue value. Knowing this, we know where all of our instance numbers fall on the index map. So we don't need to do math to get those values again. We need a target here. And the target would be just the static mesh head, because that's where the material lies on. The parameter name is going to be the instance number. So we've done all this. Oh, we need to give this 0, 1, 2, 3, 4, 5, because these are all instance numbers. And then we're going to take our array index and use that to search this map for what instance we're on. Because all we know is what index we're on. This will tell us what instance we are on. And then we can pass that assuming we convert it enough times, we can pass that as a parameter name. I don't know why it's not doing this. If I go to string, there we go. And then I can convert a string to a name. Cool. After that, now we should have our RGB values set. So let's kind of test this. Did I have to do anything after that? No, this was for the past here was for the light. So let's get just the materials working first. I don't know why I have two content browsers here. Let's drag this in. Scale it up a bit so we can see. Go to patch and patch it. And that should have given us something. So let's see what's going on. If we are passing DMX, and select my instances, then I can change the color on them. So it's claiming that I'm getting DMX. Let's count the number of cells that are in our matrix cells. So that might be why it's not triggering this for each loop. Okay, we got 48 cells in our matrix cells. Let's see what else it could be. Is this true pin firing? And if so, on what array index? Okay, that all looks right. It's on array index 0 through 35. So then we are getting our normalized matrix cell values. What does the coordinate say? And then coordinate is feeding. That should say 0 through 35 as well. Oh, negative 1 through 34. Yeah, I have a feeling let's get away from that for now. All right, so if this is firing, and that reads 0 through 35, then this should read what it finds on the map should say 0, 1, 2, 0, 1, 2, 0, 1, 2, and does that 12 times. Okay, that's correct. It's probably something really obvious at the end, actually. But it's nice to be able to go through it. Alright, so this value is giving 0, 1, 2, 0, 1, 2, 0, 1, 2. This has to be switching on to that, because I have that value. And then let's check what are my values in here called. Oh, because they're RGB 0. I get it. So what I need to do is then append this. This is my index number. I just need this to say RGB underscore. Now it'll go. There we go. So now I can bring in red, take it all away, give it green. Then I learned this trick. If I set in MA, if I set my delay to 0 through 1, and then I start hitting presets, it'll do it like that. So I have control over the cells now. Over the RGB cells, now I just need to get control over the strobe cells. And I'm going to do that a little bit separately just for organization. I can get rid of this. So I think in here I have it coming after the for each loop. Yeah. So then here, I'm going to ask myself an if branch as well. This one's going to be a little different. It's just going to compare this number and make sure that it's greater than 35. Or I could have done greater than or equal to 36. So I pass this in. If my array index is over 35, it is clearly talking about my strobe cells and not my RGB cells. So then I just need to do the same thing. I could copy and paste this one, and I will. Get normalized matrix cell values. I can branch off of this one. Branch off of this too, because I'm still finding a dimmer value. Don't need a switch on int because all of these are going to be dimmer values affecting it. So in fact, all I need to do to get my name is just subtract 35. And then I can come out of this, say set scalar parameter value on materials. And that is also on the head. The parameter name would be I need to make it minus 36 so that 36 is 0. Pass that in, and then the value it gives is dimmer. Let's try that out. Oh, this needs DMX or something. Select my 12 instances and turn those down. And then I can just highlight through them. There we go. It's a good little JDC. And then if I wanted to play with the phaser on this, whoa. Oh, because I have highlight on. Nice little chase. And then cool. So we have some sort of test sequence going now, and we can start building our light. That's a good point. If you are feeding values through, though, you might want to hit save all first and save your map, because it's kind of prone to crashing if you're making changes while things are going. So to circumvent that too, I'm going to turn my Grandmaster down, and then no actual changes are coming through. So what I'm going to do with this, wherever my fixture is, first off, let's get rid of this lens. And then I'm going to add only one light. It's going to be a rectangle light. I think I'm going to lower the attenuation radius on it to a bit smaller. That should be fine. And then in my event graph, I'm going to call that rectangle light. But first, I have to average out the color of all of these instances, and then average out the brightness of all of these cells and add those two together. So let's work on these first, because they're going to be more complicated. How I did it in my rocks was first figure out if I'm on the first instance. If I am on the first instance, then I just set the average RGB color to be the value, because I'm resetting it. I'm doing that instead of having two nodes, one to reset it and then one to apply it to the first value. So in my JDC, I'm going to make another variable called average color. So let's figure out how we did this in our rocks. First, we identify what the first instance is. Then we calculate and add up all of the other instances to that color. And then on the last instance, we divide it by our number of instances, and then we have a value that we can add. So in here, we're going to say, first we're going to make a vector out of this. And then we can pass this on the blueprint pin, because that indicates that we are done with an RGB instance. So let's go average color. This has to be a vector. So if that's not right. This gives us our instance number. I should write that here. If our instance number is equal to 0, then we set our average color and reset it to be whatever the current value is. If it's not that, then we just add those colors, whatever instance is, we add that to our average color. Okay. if our instance number is 11, well, let's do it this way. If it's 11, we're going to go out of this true pin. If it's not 11, then it's clearly either 1 through 10. So we can then add our color value to our running average color. If it's 11, then that indicates that we're on our last instance and it's time to average these together. So if it's 11, you know what we could do actually? We could do this a little backwards from this. So every time it's going to add up these values. After it adds them up, then we decide whether we divide the value or not. So if it's instance 11, then we average them. If it's not instance 11, we do nothing after adding it. So if true, then we set average color to be average color divided by 12. That gives us our average. Don't freeze, please. Oh. That gives us our average RGB vector for all of the color plates. Then we have to do basically the same thing with our strobe instances. So let's think about this again. This is going to trigger every time, but this is only going to pass during the 12 times that we're counting up our strobe values. So that said, this gives us our instance number. So we just have to do almost the exact same thing. We could probably copy this entire thing. So we set our parameter value on material. And then if our instance number is 0, we have created a variable called average brightness. And so if our instance is the first instance, we're going to set our average brightness to be 0. And I want to point out something real quick. I know this looks spaghetti-y, and I know it's cleaner to store stuff to variables and use it later, but I found that across many instances and many fixtures, if you store stuff to variables to recall later, that has to be copied to your memory. And so that will slow down the process quite considerably. If you go direct wire in, it's going to be a lot faster. I experienced that through trial and error. So if it's instance 0, we set our average brightness to be the current cell's brightness, thus resetting it. If it's not 0, we're going to add it up. So then we go average brightness equals average brightness plus the current value of brightness. After that, then we grab our instance number again. And if we're on the last instance, which again is 11, if we had 20 strobe cells, this number would say 19. And that would be our last index number. So once we're on our last index number, then we take average brightness and set it to average brightness divided by 12. Once we do that, now we've got two values. We got to figure out which one comes. So we figure out our color values first and our strobe values second. That means that this one's going to be determined before this one. So once we get this, then we add, and we can split this just to be a little bit more explicit. Because this is the color value, but these are just white values. So they're going to go to the R, G, and B cells. And then after we do that, we should divide this. We don't have to, but we should divide this by 2. In fact, it would probably be better math if we multiplied it by 0.5. I don't think computers do divide by 0 errors anymore, but you never know. So this would come after this, actually. So this plus this times 0.5 or divided by 2, that gives us our average color. Then we should have a beam mesh in here, but looks like we don't. So let's add one. Now this is one of the assets that could be shared. Let's go to our JDC1 compressed. I feel like I did some things. You know what, let's work from scratch. The rest of this tutorial has been from scratch. I could optimize later, but I want to show you guys how this is done from scratch. So copied effects, copied engine content. Let's copy our beam master over to extended. And then in our blueprint, first we got to make sure that our rectangle light that we had is parented to our head, which it is. Then we're going to add another static mesh. Oh, you know what? We do have static mesh beam. Yeah, this is what we need. Oh, but it doesn't have the material. Okay. So for some reason, the static mesh beam that was in here does not work. But if I add my own static mesh, suddenly it works. Why? I don't know. So if I move this out, now I have a beam coming from here. And then I need to re-add this. And then I can just relabel it something like static mesh beam. Oh, that explains it. So I had, where was it? These two blueprints taken out. So I probably never set the visibility on it. All right, so now, again, there we go. So if I modify the color output, it will affect that that instance. Now all I need to do is send the exact same value out to the light. Oh, because it's not a spotlight. It's a rectangle light. There we go. Now we have the light, beam, and materials all being updated. And then it looks like something's going on here. See if we can doctor it. I don't think my other fixtures look like that. The other thing I want to do is try making this a little bit more square. If I just say, beam, you're a mesh, right? Be bigger on one side. Oh my gosh, had zero expectation of that working. Cool. Well, that about sums up the actual fixture creation. Let's get the base tied in. And so for that, we'll go back to our documentation. And just look at it. So we're gonna need, on our basic mesh. Now I'm used to UE controls. We're gonna need a cube, and I'm gonna want to set the dimensions of this. So let's go to the user manual, and it was at the end. Here we go. 154 centimeters on the base. And then whatever 284 minus 178 is, 106, that's about how high it goes up to. And I'll bevel down from there. So I forgot all of those numbers. 154. 390, and then my calculated value 106. Cool, that is our base. I'm gonna hit Control R, do a little loop cut through here, and then hit SX to scale that in, and then bring these edges down by hitting GZ. Not that much though. And then I feel like there's a little bit of an offset there. And then I'm going to cheat just a little bit. I don't need a whole lot of mesh here. Just need enough to say to do loop cut here. Well, let's do two of them. Control R, mouse wheel up, and then SY to give me 2 edges right there. And they could cut into the mesh a little bit. These extend up. And then SX scale out. And then I'm just going to do one little bump up here. And then another one, SX in. That's all I need. That's all I want for mesh. Because if I've got a whole bunch of these on a rig, I don't want it taking up a lot. Furthermore, the base is bigger than the head. Yeah, I have it that way. Okay, and then this is our base now. Yeah, that's right. Export FBX, link to only selected objects. Go to Blender Exports. And we can export that. Then go to wherever we just exported that thing. Find our JDC1 body, drag it in. Then let's add it to our blueprint, which we can now, it gets a promotion now. It says it's a blueprint. What was the mode? SPIX. All right. Okay, our body is in. I did that last time too. Let's spin it 90 degrees. And then bring it up so it's kind of near our fixture. It's got an interesting choice of texture here. I guess I could... Oh, I see what's happening. I just need to lower the source height. Yeah, at least it doesn't color all of it now. And then probably adjust the barn door angle. There we go. So what I want to see is, previously I would go in the event graph and on some sort of DMX update say set the relative rotation of the head. But I'm wondering if the tilt will just do it, because the head is still the same actor that the head was before. And the yoke is still the yoke. Let's try it. If I go to position, change my tilt. Nope, it's not doing nothing. I might need to do it manually, but let's try a little bit longer. You know what I might need is push normalized values per attribute. I think I'm gonna have to tie that in. Let's see what this is supposed to be. Oh, yeah, that's something. Cool. Oh, I get it. We just need to re-export this with it facing up. And then kind of sort of do our best to center this on here. I think that has to be done in Unreal. But let's just re-export this. Shouldn't harm anything. And then re-import it. There we go. The beam is not connected to the head. There we go. Why is it pointing that way now? What? What are you doing? If I just search for tilt, go through 109 through 185 degrees. So then I go to my tilt component, 185. What's 185 divided by 2? Let's see if that's right. That looks more accurate to what a JDC1 does. I thought they went down a little more than that, but I'm eventually going to... I did not want to delete that. Go into a shop with some of these and kind of do some calibration. Now that's strange. Maybe it's the scale. No, I've never seen that before. This has happened before, and just deleting the fixture and then bringing it back actually solved the issue. I don't know why, but already it looks smoother. And if I go beneath, yeah, that should work. So if I bring this back now, patch it, then give it some values. There we go. So if it ever does that, just delete, add it back in. I'm not done actually, because I have some masters to work through. So let's go in here, and luckily these are going to be a little easier since they're not mixed in with the matrix. So we're going to go get normalized attribute values with our fixture patch as our target. Split this pin, and then let's start finding stuff. So if I remember right, our white, let's just search find white, and then we'll go from there. What we called white was our master intensity for the strobe beam. So that would be this. So this would come after we average everything. Then we multiply that by our master intensity. Then this is what goes out to our RGBs. Then in addition, we're going to find white again. Actually, we don't need to do it out here, now that I think about it. Because we're going to do it back here. It doesn't make sense to do it in two locations. So as we're setting all of our cells and adding them up, we're also going to multiply this and all coming values by our master intensity. And then the same goes, this could use some code cleanup for sure. Done. Here, we're going to find our dimmer. And that is the one that affects the RGB values. You know what? To just avoid issues down the road, let's just give this an arbitrary name. Because we have all of these dimmer attributes here. I could give this anything. Let's give it burst. Why not? Okay. Let's see if that works. I need to figure out how to grab those master intensities from my console anyway. So we're going to turn everything up to full. Oh, my Grandmaster's down, duh. So in my patch here, or in my console, if you could see, I have 3 dimmer wheels. Yeah, it looks like number 1 is for my beam. Number 2 is for my color plate. I don't know what number 3 is for. Oh, probably the effects. Okay, so that's done. And then the last thing is somehow... All right, that sums it up. Everything is in working order. In extended mode, with all of its beauty. Averaged, performant, light, and beam. And thank you everybody for watching. I know this was a lengthier one, but if you liked it, go ahead and hit subscribe. It's not going to hurt you. It might. Maybe. Depends on how you take it. Oh, I have to get rid of print string in here.